All right, it is the last section before our test on 6.1, 6.2, and 7.1 through 7.3. And today we're not necessarily doing anything new. You can still do the distribution / FOIL or box method for these problems, but what we're going to do is we're going to look at some special products, special binomial times binomials. So the first one we're going to look at is the perfect square trinomial, and that is when we have a parenthesis squared. Now, this is different than something that looks like this. When we did exponents in chapter 6, in this case, because everything is connected by multiplication, we basically distribute that exponent. And this would be 2 to the second, x to the second, y to the fourth, or in other words, 4x squared, y to the fourth. But in this case, when it says the parenthesis x plus 3 squared, this means x plus 3 times x plus 3, okay? It is not x squared plus 9. So anytime you see a parenthesis squared, the first thing you should do is rewrite it. So it's parenthesis times parenthesis, just like we did here. Once you rewrite it, you can see it's just like what we've been doing. So whatever method you choose, you are going to get this. Combining like terms, our final answer will be x squared plus 6x plus 9. So the trick is that you have to rewrite it. When you're given one parenthesis squared, you have to rewrite it so that you can then multiply appropriately. Now, you might notice, as it says over here, and that is your middle term, or your first term is always x times x. Your last term will be, in this case, the 3 times 3. But then the middle term was 2 times x times 3, or 3x. Because when you have the same parenthesis times itself, your outside and inside terms, the two that you add together, are going to be the same. And so you end up with 2 times whatever that is. But it's not that knowing the pattern's not important. Knowing how to get the answer is, and remembering to rewrite it as 2 parentheses is the key. So this one, you can pause and then try it on your own and then push play. This one's going to be x minus 5. So that's going to give us x squared minus 5x plus 25. Again, notice those middle terms are the same when we have the same parenthesis times itself. And our final answer is going to be, 25 here, plus 25. X squared minus 10x plus 25. So when you see those types of problems, make sure you rewrite them and multiply appropriately. The other problems that we're going to see today are the difference of 2 squares. And they're called that because the answer is going to look like that. In other words, we're used to all of our answers looking like a trinomial with an x squared term, an x term, and a number. But in these problems, and we'll see what's special about them, your answer won't have a middle term. It's going to be just like the first and the last, if we were talking FOIL here. So notice the problems we're given now, it's not the same parenthesis times itself, but notice they look the same except one's positive and one's negative. When we have that and you apply whatever method you want, notice what happens. We're going to get x squared minus 3x plus 3x minus 9. And when we go to combine like terms, they cancel out. And so our answers look special or different because there's no middle term. And it's when we have the same thing times itself except one's positive, one's negative. And this is the difference. Difference means subtraction of 2 perfect squares. X squared, and then 9 is also a perfect square. So your answers turn out to be that difference of 2 squares. So similarly, when we do this last one, and again, you can try this first, pause it, and then push play when you're done. But same thing's going to happen. We're going to get plus 7x minus 7x minus 49. These cancel out. Final answer, x squared minus 49. The difference of two perfect squares. So bottom line is do them just like you did any other ones, but if you notice your problem is the exact same parenthesis times itself, rewrite it, and your answer should be, twice, the middle number twice of your factors, and then, or your two middle terms are the same, and then when it's two parentheses that look alike but one's positive and one's negative, those middle terms should cancel out, and your answer should look like these.